Example 4.4. An element delta L equal to delta X I cap is placed at the origin and carries a current I equal to 10 amps. What is the magnetic field on the y-axis at a distance of 0.5 meter and delta X equal to 1 centimeter? Okay. First, we will see what are the given values. I equal to 10 ampere. Current is flowing here, that is 10 ampere. And delta Ix, length of the current carrying element is 1 centimeter. We will convert into meter, 10 to the power minus 2 meter. We have to find the magnetic field at point P, that is at the distance of 0.5 meter. Now, how to find magnetic field? Magnetic field due to a current carrying conductor, current carrying element is given by Biot-Savart law. Yes, Biot-Savart law is given by dP equal to mu 0 by 4 pi I ds sin theta by r square. Now, can you tell me what is theta here? We are finding magnetic field at B. Current is like this. So, this angle theta is 90 degree. Theta value 90 degree, R at a separation, delta L, R value is given as, what is our separation? Current carrying element and the point where we have to find the magnetic field. This is R, right? So this value is given as point. Now we'll substitute the value. B equal to mu 0 value is 4 pi 10 to the power minus 7. 4 pi get cancelled. 10 to the power minus 7. I into dl, theta is 90 sin 91 and divided by r square. Current is 10, dl value, dx value 10 to the power minus 2, r value 0.5 whole square. If you simplify, you are getting the answer 4 into 10 to the power minus 8 Tesla. Now, magnetic field is a vector quantity. This is the magnitude. What will be the direction? Use right hand thumb rule. If you are keeping right hand thumb and curl the finger, magnetic field will be outward. Outward means that is along positive z axis.